I want you to look around for a second. Just look at the space between you and the wall, or, look at the space between your hands,
Right.
or even just focus on the empty air right in front of your face. What do you actually see there?
Most people would say absolutely nothing.
Exactly. If you are like most people, you see nothing. It is just empty space. I mean, we are taught to think of it as this infinite, featureless void.
Yeah, a sort of blank stage.
Right, a blank stage where the actual stuff of the universe, like the planet, the stars, the atoms, you and me, where all of that stuff happens.
The backdrop.
Yeah, the backdrop. But what if that empty space isn't empty at all? What if you are actually looking at a rigid, infinite geometric structure?
It's a wildly counterintuitive idea.
It really is. Like, imagine an invisible architecture built on some of the most fundamental mathematics in the cosmos.
It requires a complete rewiring of our baseline assumptions about physical reality. I mean, we're incredibly accustomed to treating the vacuum of space as just a passive backdrop, right? A void.
Yeah.
But in the framework we are examining today, that passive backdrop does not exist. The stage itself is the primary actor.
Wow.
Yeah, and the particles and planets are just localized vibrations or expressions of the stage's underlying geometry.
And that geometry is exactly what we are plunging into for this deep dive. We are exploring the fundamental architecture of the quantum vacuum.
It's a massive topic.
It is. And our map for this journey is a 2026 paper by independent researcher George James Dukas. The title is, well, it's dense,
Very dense.
but it outlines exactly what we are going to tear apart today. It's called Spin Correlation of Short-Range Lambda-Anti-Lambda Pairs as a Direct Signature of Lattice Vacuum Density and Transdimensional Unified Field Theory.
I know the title is heavily loaded with specialized terminology.
That is an understatement.
But the core objective of the paper is actually very focused. It takes a highly anomalous, very specific data point from a major particle physics experiment, and it attempts to prove that this data point is not an error. It's not a statistical fluke. It's actually a direct measurement of the invisible structure of the universe.
Which is just staggering to think about. Our mission today is to unpack that incredibly specific number. We are going to look at how it was observed in a particle collider, and we are going to explore the author's radical proposition.
The idea that this number is the literal mathematical fingerprint of the vacuum of space itself.
Exactly. Now, before we get into the heavy machinery and the quantum mechanics, I want to give a quick reminder to you, our listener.
An important disclaimer.
Yeah, very important. This theory, Transdimensional Unified Field Theory, or TDUFT, is highly unorthodox. I mean, it fundamentally challenges the core assumptions of our current standard model of particle physics.
Specifically quantum chromodynamics.
Right. And we are here today purely as impartial guides. Our role is to explore the arguments, break down the intricate mathematics, and unpack the bold physical claims laid out in this paper.
We are not endorsing a specific side of theoretical physics here.
Not at all. We are here to help you understand the mechanics of this debate and, honestly, to just marvel at the sheer scale of the ideas being proposed.
Because the landscape of theoretical physics is defined by rigorous, often fiercely contested debate. I mean, mainstream theories become mainstream because they survive decades of experimental verification.
They run the gauntlet.
Exactly. But they always carry unresolved mysteries. Alternative frameworks like TDUFT exist to attack those unresolved mysteries by proposing entirely new foundational rules.
So our objective is to synthesize this specific framework, to understand the causal mechanisms the author is proposing, and to see how those mechanisms theoretically alter our understanding of the physical world.
It's going to be a fascinating breakdown.
Okay, let's unpack this. We cannot talk about the invisible architecture of the universe without first talking about the very visible, multi-billion-dollar machine where this specific number was found.
The relativistic heavy ion collider.
Yes, the RHIC. The entire premise of this paper hinges on a real-world experiment conducted there. This is located at Brookhaven National Laboratory in New York.
To really grasp the significance of the data, you have to visualize what the RHIC actually does.
Paint a picture for us.
Well, it is essentially a massive underground racetrack for subatomic particles. It uses these powerful, supercooled electromagnets to take protons, the positively charged particles sitting in the nucleus of an atom,
Right.
and it accelerates them around a 2.4-mile ring.
A 2.5-mile underground ring.
Yeah. and it pushes them until they are traveling at 99.995% the speed of light.
Which is, I mean, that speed is almost incomprehensible. And once they are moving that fast, you don't just let them race, right? You cross their paths.
Exactly. You steer these beams of near light speed protons directly into each other. You smash them together.
And the physics of what happens in that collision is totally counterintuitive.
It really is. I mean,
Yeah.
when two cars crash, you get bent metal and broken glass.
Pieces of the original cars.
Right. But when two protons crash at relativistic speeds, the kinetic energy of the collision is so immense that it actually creates entirely new matter out of the available energy.
Following Einstein's famous equation relating energy and mass, E equals mc squared.
Exactly. The space inside the collision chamber reaches temperatures hundreds of thousands of times hotter than the core of our sun.
So we are recreating conditions that haven't existed since fractions of a second after the Big Bang.
It is an environment of absolute violence.
Absolute violence. And within that extreme violence, we have to look at what the quantum vacuum is actually doing.
Because in standard quantum mechanics, the vacuum is never truly empty. It is constantly boiling with what physicists call virtual particles.
Okay, let's break down virtual particles for a second.
Sure, these are pairs of particles and antiparticles that spontaneously pop into existence. They borrow a tiny amount of energy from the universe and then instantly annihilate each other to pay the energy back.
So they basically blink in and out of reality.
Right, because this happens on such an unimaginably short timescale, it doesn't violate the conservation of energy.
They exist purely as mathematical probabilities. They are essentially ghosts haunting the empty space inside the collider.
That's a good way to put it. But when that proton collision occurs, the massive injection of real energy changes the rules.
It disrupts the haunting.
Yeah, exactly. The collision environment interacts with these virtual pairs. Specifically, the RHIC experiment was observing interactions with virtual strange quark pairs.
Okay, quarks, the fundamental constituents of matter.
Right. And the strange quark is a heavier, more exotic variety than the up and down quarks that make up normal everyday matter like you and me.
So we have these ghostly, virtual, strange quarks popping in and out of existence in the vacuum.
Yes.
And then the proton collision acts like a massive lightning strike.
It pumps enough real energy into the local vacuum to cross a physical threshold.
Yeah.
It takes those virtual strange quark pairs and promotes them.
Promotes them. I love that term.
It literally drags them out of their ghostly temporary state and forces them to become real, on-shell, observable particles.
Okay, so they go from being mathematical possibilities to actual physical stuff we can measure.
Exactly. Through a process called hadronization, these strange quarks bind with other quarks created in the collision to form composite particles called hyperons.
Hyperons.
Yes. Specifically, they form a lambda hyperon and its antimatter counterpart, an anti-lambda hyperon.
So we pull them out of the void, they materialize in the collision chamber, and they start flying outward toward the detectors.
Right. But the Brookhaven scientists aren't just taking attendance here.
They aren't just counting how many lambda particles hit the wall.
No, they are measuring the physical properties of these newly minted particles at the exact moment they enter reality. And the property we care about for this deep dive is spin.
Okay, spin. Now, this is a purely quantum mechanical property,
Yeah.
right? It does not mean the particle is physically spinning like a top.
Correct. It's a bit of a misleading name. It means it has intrinsic angular momentum. It behaves as though it has a tiny internal compass needle pointing in a specific direction.
A tiny compass needle. I like that analogy.
So in the RHIC experiment, the detectors track the decay products of these hyperons to reconstruct the exact orientation of those internal compass needles.
At the exact moment the lambda and anti-lambda particles were created.
Right, while they were still in extremely close proximity.
So they are looking for a correlation. Like if you pull a particle and an antiparticle out of the vacuum at the exact same time, do their internal compass needles point randomly?
Are they completely independent of one another?
Or is there a pattern?
Well, the experiment revealed a definitive pattern, a short-range spin correlation.
So the alignment of the lambda and the anti-lambda spins was not random at all.
Not random. The crucial measurement, the number that this entire paper revolves around, is the measured value of this correlation.
Okay, Davis, that number.
The value is 0.388.
0.388. And this wasn't just, a blip in the data on a Tuesday afternoon.
Not at all. The statistical significance of this measurement is 4.4 sigma.
Which is massive in physics.
Huge. In experimental physics, a 3 sigma result is considered strong evidence. And 5 sigma is the absolute gold standard for an outright discovery.
So 4.4 is right on the edge of undeniable truth.
Exactly. A 4.4 sigma result means the probability that this correlation is just a random statistical fluctuation in the background noise, it's less than 1 in 100,000.
Wow. So it is a robust, verified, physical phenomenon. The hyperons are undeniably communicating a shared alignment at the moment of their creation.
Which brings us to the massive headache this causes for standard physics.
Right, because the rulebook we currently use to understand quarks and hyperons is quantum chromodynamics, or QCD.
Yes, and QCD expects some level of correlation. It predicts a triplet-dominated state because of how angular momentum works.
But QCD cannot independently generate the number 0.388.
That's the problem. Standard QCD is highly effective at describing the strong nuclear force. But when confronted with this specific, highly precise spin correlation value, it hits a wall.
It just stalls out.
There is no foundational equation in QCD that you can solve from first principles that will naturally output the number 0.388.
So how do mainstream physicists deal with that?
To make the theoretical models match the data coming out of the RHIC, physicists have to introduce additional model assumptions.
They have to manually tweak the math.
They manually adjust the parameters of the simulation to force the outcome to match reality.
You know, it is like performing a magic trick. Imagine you reach into empty space, grab 2 blank coins, and throw them onto a table.
Oh, okay.
And when you look down, you find that almost 40% of the time, the coins have landed on the exact same face.
Right.
Now, you know the coins didn't physically talk to each other while they were in the air, so you are left with a very unsettling question.
How do they know?
Exactly. Was the empty space you pulled them from already holding them in a specific predetermined pattern before they ever materialized on the table?
And standard physics looks at those coins and says, well, there must be some complex invisible wind in the room that we need to model to explain why they land this way.
Right. They start adding complicated rules to the room to explain the coins.
That captures the dilemma perfectly. If your foundational theory requires ad hoc adjustments to explain a fundamental correlation, the theory is arguably incomplete.
It's missing something fundamental.
The central thesis of Ducas's paper is that the RHIC collision is acting as a high-energy, high-resolution photograph of the vacuum itself.
A photograph of empty space.
Yes. The energy of the collision freezes the underlying pre-existing state of empty space and transfers that state directly into the spin orientations of the hyperons.
So we take the photograph, and standard QCD basically can't recognize the shape in the background without drawing over it with a marker. But this paper argues we don't need to draw anything. What if there is a framework that requires 0 extra parameters?
A framework where 0.388 isn't a puzzle to be solved, but a fundamental geometric constant baked into the literal fabric of reality.
And this is the exact transition point into transdimensional unified field theory.
Yes. The paper asserts that we have fundamentally misidentified the nature of the vacuum.
It is not a void filled with random quantum fluctuations.
No. It is a highly ordered, infinite geometric sphere.
So we need to completely abandon the idea of an empty room. Let's look at the specific architecture TDUFT proposes.
The theory introduces the concept of the infinite lattice.
The lattice, PHI.
Right. It claims that space is a rigid, eternal crystal. But it isn't made of physical matter.
What's it made of?
It is made of pure structural mathematics.
Okay, pure math. And the architecture of this proposed lattice is dictated by a single pervasive mathematical constant, right?
The golden ratio. In mathematics, this is denoted by the Greek letter phi.
And the golden ratio is something most people have encountered, even if they don't realize it.
Oh, definitely. It's everywhere in nature.
Yeah, we see it in the spiral of a nautilus shell, the branching of trees, the way seeds arrange themselves in the center of a sunflower.
Even in historical architecture like the Parthenon.
Right. Numerically, it's about 1.618. To calculate it exactly, you take 1, add the square root of 5, and divide the whole thing by 2.
And the golden ratio has unique algebraic properties that make it incredibly prevalent in self-organizing systems.
Like what?
Well, for example, if you square phi, it is equal to phi plus 1. You take the reciprocal of phi, so 1 divided by phi, it is equal to phi minus 1.
It just constantly loops back on itself?
Exactly. It is a number defined by its own internal symmetry. And TDUFT postulates that this symmetry isn't just an aesthetic curiosity in nature.
It's not just a pretty spiral on a shell.
No, it is the fundamental building block of spatial dimensions. But to construct the math of the vacuum, the theory introduces the conjugate of phi.
The conjugate.
Yes. The paper calls this the time, or contraction, operator. It is represented by the Greek letter Ti.
PSI. Okay, so if phi is 1 plus the square root of 5 divided by 2, the conjugate, CSI, is 1 minus the square root of 5 divided by 2.
Correct. Which result in a value of approximately negative 0.618034.
Okay, so we have phi for expansion and psi for contraction.
Right. In the geometry of the TDUFT lattice, the expansion of space is governed by phi, and the contraction or localized density of the vacuum is governed by psi.
And the theory claims that the quantum vacuum possesses a baseline geometric density.
Yes. And the mathematical operator that defines this second-order vacuum density is exactly psi squared.
Okay, so we take that contraction operator, that negative 0.618, and we square it.
And because you're squaring a negative, the negative cancels out.
Right, and we are left with a very specific, infinitely long decimal. I am going to read the first chunk of it out loud because the entire validity of this alternative framework rests on this specific sequence of numbers.
It's the core of the argument.
Yeah. When you square psi, you get 0.3819601250105, and it just keeps going.
The origin of this number is purely algebraic. It requires zero physical input.
We didn't have to measure anything to find it.
Exactly. We did not measure the mass of a proton or the speed of an electron to find this value. It is derived entirely from the fundamental geometry of the golden ratio.
Just pure math.
Just pure math. And according to the mathematics of TDUFT, this pure number 0.381966 is the baseline spin correlation that any matter-antimatter pair should possess when it is extracted from the vacuum lattice.
Okay, I have to stop the train right here. I'm throwing up a massive red flag.
I know exactly what you're going to point out.
I mean, we have a problem, right? The pure math of the lattice predicts a spin correlation of 0.381966.
Yes.
But we just spent 20 minutes establishing that the multi-billion-dollar collider at Brookhaven measured a real-world correlation of 0.388.
There's a gap.
Yes. If I subtract the theory from the reality, I have a discrepancy of about 1.6%. Now, if my car gets 1.6% less gas mileage than the sticker claims, I barely notice.
Sure, in everyday life, it's nothing.
But particle physics operates on a level of precision where theories are discarded for being a billionth of a decimal point off. A 1.6% gap between the golden ratio math and the actual machine output isn't a rounding error, it is a canyon.
It is a massive canyon.
So why doesn't that immediately invalidate this entire lattice theory? Are we just saying it's close enough?
Not at all. That is the exact crucible where this theory either survives or falls apart.
Yeah.
In precision high-energy physics, you cannot sweep a 1.6% anomaly under the rug.
Right.
If TDUFT simply claimed 0.38196 was the final observable answer, the theory would be dead on arrival.
Absolutely dead.
But the architecture of the theory does not stop at the pure mathematics. The paper introduces a mechanism to bridge the gap between the perfect abstract geometry of the lattice and the violent, messy reality of the collider.
Okay, how does it bridge the gap?
It bridges this gap by invoking one of the most unbreakable rules in physics.
Entropy.
Entropy, the second law of thermodynamics.
Yes.
The universal tendency of all ordered systems to move toward disorder over time.
Yeah.
Things fall apart.
Exactly. The paper details what it calls the entropy completion.
Let's break that down.
Okay, if we take the observed central value from the RHIC experiment, the physical reality of 0.38800000000, and we subtract the ideal perfectly ordered vacuum density value of 0.381960113.
The pure math number.
Right. The remaining gap is a highly specific value at 0.0060339887.
So the gap itself is mathematically precise. Yes. The author defines this gap as delta entropy. And it is critical to understand the mechanism being proposed here.
Okay, I'm listening.
This gap is not a secondary field being layered on top. It is not an arbitrary force invented to make the equations balance.
It's not the invisible wind from our coin analogy.
Exactly. It is defined geometrically as a finite transition correction.
Finite transition correction. Let's break down that transition. We are moving from one state of being to another.
Right. We return to the virtual strange quark pairs. When they exist as virtual particles, they are perfectly integrated into the flawless mathematical order of the infinite lattice.
So when they are ghosts, they are mathematically perfect.
Yes, they are part of the pure 0.381966 geometry, but then the proton collision occurs.
The lightning strike.
The energy of the collision violently extracts these particles from the perfectly ordered lattice and forces them to materialize in the continuous thermal environment of standard spacetime.
So you are dragging them out of a realm of pure mathematical perfection and dropping them into a blindingly hot, chaotic, physical collision chamber.
And that transition carries a physical cost. You cannot move a piece of information from a state of perfect absolute order into a continuous thermal reality without acquiring local disorder.
You inevitably acquire entropy.
In the mathematics of TDUFT,
Mm.
every time a limit is reached, every time you transition from the discrete lattice into the observable continuum, the system acquires a convergent infinite harmonic attenuation series.
Okay, wow. Convergent infinite harmonic attenuation series.
I know, it's a mouthful.
Let's translate that into something visual. Imagine you have an incredibly complex, flawless digital blueprint for a skyscraper.
Okay, I see where you're going.
In the computer software, the walls are perfectly parallel to 1,000,000 decimal places. The angles are exactly 90 degrees. That digital file is the pure 0.38196 lattice math.
It's perfect because it's purely theoretical.
Right. But a digital file doesn't keep the rain out. You have to actually construct the building.
You have to transition the blueprint into physical reality.
Yes. And when you pour the physical concrete, the temperature of the air slightly alters how it cures. When you place the steel beams, microscopic variations in the metal create slight deviations.
The workers get tired.
The wind pushes on the cranes. Exactly. The physical building will inevitably contain thousands of tiny structural deviations from the perfect digital file.
And that structural deviation is the entropy of existence.
Right. The final physical building is the 0.388.
The blueprint analogy highlights the exact causal mechanism perfectly. The pure geometry is the blueprint. The transition into a physical state, the hadronization of the quarks in the collider, forces the system to absorb the entropy of construction.
The messy reality of building it.
And the leading residual term of that entropy shift is exactly that delta value. It shifts the baseline upward by a few parts in 1,000.
So the math actually accounts for the messiness.
Exactly. When you take the pure lattice density of 0.381966 and add the inescapable physical entropy of entering reality, that 0.006034.
The final mathematical sum lands flawlessly on 0.388.
Yes. The theory's prediction falls dead center into the experimental observation.
That is just elegant. The author isn't inventing a new rule to fix the math. They are relying on the fact that reality is inherently messy.
They use the unavoidable necessity of the second law of thermodynamics to complete the equation.
It forces a massive philosophical shift in how we interpret experimental data, doesn't it?
It really does. Standard physics often views the gap between theory and observation as a lack of sufficient modeling parameters.
Yeah.
Like, just haven't drawn enough rules on the chalkboard.
But TDUFT views the gap as a fundamental feature of reality itself.
Right. The imperfections we measure are the literal thermal fingerprints left behind when perfect geometric information is forced to interact with the physical environment.
Okay, so we have the birth of the hyperons. The violent transition into reality adds entropy, bumping the correlation from the pure lattice baseline up to the measured 0.388.
Right.
But these particles don't just materialize and freeze in place. They are born in a high-energy collision, which means they are immediately flying apart at tremendous speeds.
Very fast.
So if this entropy correction is a physical mechanism that affects them as they enter reality, it must continually affect them as they travel through reality, right?
Which introduces the next critical phase of the paper's argument: spatial decoherence.
Decoherence, the falling apart of the connection.
Right. The correlation is measured at its strongest point, right at the moment of creation. But the RHIC experiment also measured what happens to that correlation as the physical distance between the lambda and the anti-lambda increases.
As they fly away from each other.
Yes, and the paper provides a precise mathematical formula to describe this decay.
The decoherence formula. It dictates that the correlation at a given separation, which the paper labels as delta, is equal to the starting value, 0.388.
Multiplied by the mathematical constant E, raised to the power of negative gamma phi delta.
Okay, let's dissect the mechanics of that formula. The presence of e to the negative power signifies an exponential decay function.
Right. As the delta variable increases, as the particles get further apart from one another, measured either by the physical angle between their trajectories or their rapidity separation in the collider, the spin correlation plummets exponentially.
The internal compass needles start to lose their alignment very quickly.
They do.
But what is actually physically causing the needles to drift?
The paper attributes this to lattice propagation.
Meaning just moving through the lattice?
Exactly. Remember, the particles are not flying through an empty void. They are traveling through the structured lattice. The shared orientation state they were born with, that memory of their joint creation, is subjected to continuous structural friction as they cross the lattice nodes.
Structural friction.
The mathematical term for this friction is the entropy current divergence. The further they travel, the more entropy acts upon the system, actively erasing the original alignment.
You know, it is like two people holding hands and trying to walk perfectly and step out of a massive, chaotic mosh pit at a concert.
That's a great visual.
As long as their hands are locked together, their movements are highly correlated. They move as one unit, that is the 0.388, right at the center of the collision.
Right.
But the crowd is constantly bumping into them, exerting physical pressure. The moment they lose their grip on each other and try to navigate the crowd separately, the chaotic collisions of the people around them begin to degrade their shared path.
The mosh pit takes over.
Yeah. The further apart they drift in the crowd, the more the entropy of the mosh pit forces their internal compasses to point in completely different directions until their movements are totally disconnected.
The physical environment actively strips away the initial quantum coherence. And what makes this compelling from a theoretical standpoint is that standard physics struggles to provide a fundamental first principles reason for this exact rate of exponential decay without, again, adding manual parameters.
Standard physics has to program the mosh pit manually.
Right, but TDUFT provides the decay curve naturally as a geometric consequence of the particles dragging their state through the lattice.
Now, any scientific claim requires rigorous control groups.
Absolutely essential.
You have to prove that the 0.388 correlation and its subsequent decay isn't just a systematic error in how the Brookhaven detectors read data.
You need to know it's not a glitch in the machine.
So the paper relies on 3 specific control scenarios from the RHIC data that serve to validate the lattice geometry. Let's look at what the experiment showed didn't happen.
The absence of a signal can be just as illuminating as the presence of one.
Definitely. The first major control group involved same sign pairs. The 0.388 correlation was found exclusively in matter-antimatter pairs, a lambda paired with an anti-lambda.
Right.
But the Brookhaven scientists also analyzed pairs of identical particles. They looked for correlations between 2 lambda particles or 2 anti-lambda particles created in the same collision.
And when they measured the compass needles of 2 identical particles, the correlation was 0.
Complete randomness.
The data showed absolutely no short-range alignment. Standard models have various ways of addressing this, but TDUFT explains it through a purely geometric rule it calls antisymmetric torsion cancellation.
Antisymmetric torsion cancellation. We need to visualize the geometry here. How does a particle interact with a lattice differently than an antiparticle?
In the TDUFT framework, particles and antiparticles represent opposite directional orientations across the structure of the lattice.
Like moving left versus moving right.
Sort of. A matter-antimatter pair represents what the paper calls an adjacent tier crossing. Their opposite natures allow them to couple with the torsion, the twisting energy of the lattice in a complementary way.
And that's what captures that 0.381 baseline density.
Exactly. However, a same sign pair like 2 lambdas represents parallel tier crossings.
So they're trying to move through the geometry in the exact same structural way.
And because the golden ratio geometry is fundamentally antisymmetric, when 2 identical particles attempt to draw upon the local torsion vector in parallel, the geometry forces the torsion to cancel itself out.
It just zeroes out.
It is structurally impossible for parallel crossings to capture the vacuum density. Without the torsion, the density operator vanishes entirely,
The mathematical equation drops to a hard 0.
matching the experimental data perfectly.
So the geometry physically prohibits 2 matter particles from sharing the alignment. That provides a rigid logical mechanism for the null result. The second control group looked at a completely different type of particle created in the collision, kaons. And when they measured kaon pairs, they also found 0 correlation.
Yes, because kaons have a different quark composition and a different mass profile than the miparons.
So they don't fit the lock.
Exactly. Within the lattice framework, they do not possess the necessary dimensional criteria to interact with the second-order vacuum density operator in the same manner. They fail to couple with a specific torsion that aligns the hyperon spins.
Okay, here's where it gets really interesting. The third control wasn't a physical measurement in the collider. It was a digital simulation.
This is a crucial piece of the puzzle.
They ran the precise parameters of the proton collision through a Monte Carlo simulation program called PYTAA.
PYTAA is effectively the gold standard for simulating high-energy physics.
It is a supercomputer program loaded with all the accepted mathematical rules and parameters of standard quantum chromodynamics.
Everything mainstream physics knows is in that software.
Right. And when they simulated the exact same lambda and anti-lambda pairs in PYTHIA, the computer returned zero correlation.
The simulation was completely blind to the phenomenon.
Let's just sit with the implications of that for a second. We have a real physical machine that definitively measures a 0.388 alignment.
In physical reality,
And we have our best, most sophisticated digital model of the universe trying to replicate that exact event using standard physics. And the model sees absolutely nothing.
nothing at all.
Does that not definitively prove that our standard theoretical models are fundamentally missing an underlying layer of reality?
It heavily reinforces the argument that the standard model is incomplete. The failure of the PYTHEA simulation is not a failure of computing power.
Right, it's not a hardware issue.
No, it is a failure of foundational inputs. The simulation cannot output a geometric lattice correlation because it does not contain the mathematics of the phi lattice. It treats the vacuum as a blank background.
Just an empty stage.
Exactly. Dukas argues that the null result in PYTHI, contrasted directly with the positive result in the physical collider, is the ultimate proof that the correlation relies on geometric constraints.
The specific interaction of matter and antimatter with the golden ratio structure?
Yes, constraints that standard QCD entirely lacks.
We have spent a lot of time talking about these geometric constraints. We keep referencing density operators, torsion vectors, and entropy divergence.
There's a lot of moving parts.
It sounds like we are describing the moving parts of a massive cosmic engine. But how do all these parts actually connect? Where is the blueprint for this engine written down?
This is where the paper reveals its most ambitious theoretical component.
The grand unified theory aspect of it.
Right. The author does not invent separate disjointed equations to explain the initial correlation, the same-sign cancellation, and the spatial decoherence.
They're all linked.
The entire framework, every single mechanism we've discussed, is derived from one single, unified string of mathematics.
So the author claims there is a single equation that dictates the behavior of the quantum vacuum.
Yes. The paper refers to it as the covariant master unification equation, or Nexus 1, operating on the infinite phi lattice.
Nexus 1. It sounds like something out of a sci-fi novel.
It is a differential equation that attempts to describe the exact relationship between the structure of space, the energy moving through it, and the entropy that degrades it.
Okay, I am looking at this equation in the paper right now, and to a layperson, it looks like an impenetrable wall of Greek letters and calculus symbols. I need you to break this down for us. What are the actual components of this master unification equation?
Okay, let's walk through it. The equation is written as the partial derivative with respect to tau of d sub n,
Okay.
equal to b phi times v sub t, times the discrete lattice gradient of d sub n minus delta, minus the natural logarithm of phi, times the entropy current divergence.
Okay, let's translate that wall of math into physical concepts. We start with d sub n. What is that?
D sub n represents the dimensional node field at tier n.
What does that mean in simple terms?
In a three-dimensional grid, a node is simply an intersection point. This term specifies exactly which specific location and layer of the infinite lattice we are calculating.
Ah, okay, so it provides the literal physical address in the lattice architecture.
Exactly. Next, the equation multiplies that address by b phi.
B phi. What's the B?
B phi is the antisymmetric golden ratio beta tensor.
A tensor.
Yes, a tensor is a mathematical object that describes how values change across different dimensions. But the crucial word here is antisymmetric.
Antisymmetric, that's the rule from earlier.
Yes, this single term is the mathematical enforcer that causes the same sign particle pairs to cancel out to zero. The geometric rule that forbids identical particles from sharing the torsion is hard-coded directly into this tensor.
And it multiplies that tensor by v sub t, the local torsion vector.
Right. Torsion, in this context, refers to a literal geometric twist within the fabric of the lattice.
It's like twisting a piece of fabric.
If you imagine a flat grid of rubber bands, Torsion is what happens when you pinch a point and twist it. The torsion vector dictates how the energy of the vacuum twists the internal compass needles of the particles, forcing them into that specific alignment.
So let me recap. The first half of the master equation establishes the physical address of the event, applies the geometric rules that allow or forbid the connection, and introduces the twisting energy that actually aligns the particles.
Spot on.
But then there is a minus sign, and the second half of the equation brings in the natural log of phi and the entropy divergence.
The second half of the equation represents the cost of reality.
The cost of reality, the entropy.
The term del S of S ent dn is the mathematical representation of the entropy current divergence. This is the structural friction.
Right.
This is the engine of spatial decoherence that slowly erases the alignment as the particles travel away from each other.
The mosh pit tearing the hands apart.
Precisely. And it is this exact same entropy term that provides the finite transition correction we discussed earlier.
Oh, wait, the transition correction.
Yes. It's the mechanism that bumps the pure mathematical density of 0.38 up to the observable 0.38 when the particles materialize in the collision chamber.
Wow. So this one equation dictates the perfect baseline density derived from the golden ratio. It dictates the twisting force that aligns the particles. It enforces the rule that prevents identical particles from aligning. And it calculates the exact amount of physical friction that will eventually destroy the alignment.
All functioning simultaneously within one mathematical expression.
If we connect this to the bigger picture, the implication is just staggering. The author is presenting this equation as a foundational source code.
And it's crucial to understand that Dukas did not invent this equation solely for this 2026 paper to solve a discrepancy in hyperon spin.
He didn't just reverse engineer the math to fit the RHIC data.
Exactly. This equation utilizes pre-existing operators from the broader theoretical framework of TDUFT. The paper simply takes the data from the RHIC experiment, plugs it into the existing lattice mathematics, and demonstrates that the output flawlessly matches the physical observation.
That drastically changes the context. It isn't a custom-built solution for one specific problem. It is a universal framework being applied to a totally new data set.
Right.
But if this master equation is truly the source code for the vacuum of space, its influence cannot be isolated to a single hyperon experiment in New York.
No, it would govern everything.
If the universe is built on this lattice, the watermark of this geometry should be visible everywhere. It should dictate the most fundamental constants in physics.
The author is well aware of that requirement. The appendices of the paper pull back the scope to demonstrate how the lattice mechanics apply to the broader universe.
So they go big.
Very big. The claims are expansive. TDUFT suggests that the mass spectra of fundamental particles, why an electron has its specific mass, why a proton weighs what it does, are all determined by geometric scaling factors of phi.
Everything scales to the golden ratio.
It claims to geometrically derive the resonance of the Higgs boson, the orbital periods within gravitational reservoirs, and even the nature of gravitational attraction itself.
Utilizing higher even powers of the contraction operator.
Yes.
But the appendix that forces the most extreme paradigm shift deals with the absolute bedrock of modern physics. The speed of light.
Now we're getting into relativity.
Right. Standard physics, building directly on Einstein's theory of special relativity, treats the speed of light in a vacuum represented by the letter c as a rigid, unchangeable constant.
It is approximately 2.9979 times 10 to the 8th meters per second.
And in mainstream physics, that speed limit is a fundamental property of the universe. It dictates causality, time dilation, and the relationship between mass and energy.
You cannot mess with the speed of light in standard physics.
But TDUFT suggests that the number we measure for the speed of light isn't the true baseline. It introduces the concept of an ideal Trinitarian velocity.
Right. It claims that the pure geometric mathematics of the lattice establish a perfect baseline velocity of exactly 3 times 10 to the 8th meters per second.
A perfectly round integer. 300 million meters per second, exactly.
Yes. But obviously, when we measure the speed of light in a laboratory, we do not get exactly 300,000 kilometers per second.
We get a slightly slower, messier number, 2.9979.
Which brings us right back to the central theme of this entire theory. How does TDUFT explain the gap between the perfect integer of 3 and the messy reality of 2.9979?
Oh, I think I see where this is going.
It relies on the exact same mechanism used for the hyperon spin, the entropy completion.
The convergent infinite harmonic attenuation series.
Yes. The theory argues that a photon of light is not traveling through an empty void. It is propagating through the structured phi lattice.
And as it moves, it experiences structural attenuation. It interacts with the entropy of the vacuum.
Exactly. The physical speed of light is simply the perfect geometric speed, dragged down and attenuated by the inherent friction of moving through a physical reality.
It is the blueprint analogy applied to the speed limit of the cosmos. The perfect digital blueprint says the speed is 3, but driving the physical par through the actual physical lattice slows it down to 2.9979.
Exactly. But the implications for light get even more controversial. We need to talk about vacuum anisotropy,
Anisotropy.
and specifically the Brillat-Hull experiment from 1979.
Okay, this requires a brief detour into the foundational assumptions of relativity. Standard special relativity demands that the vacuum of space be perfectly isotropic.
Right. Isotropic means that empty space possesses no internal structure, no grain, and no preferred direction.
It looks and behaves exactly the same whether you are looking up, down, left, or right.
Because if space is completely empty, there is nothing there to resist or alter the path of light. Therefore, the speed of light must be absolutely identical in every possible direction you measure it.
The mathematical variation in the speed of light depending on direction, which is represented as delta c over c, must be a hard mathematical 0.
It has to be 0. If it is not 0, the foundation of special relativity begins to crack.
So in 1979, Elaine Burlet and John L. Hall conducted an incredibly precise experiment to verify this isotropy.
Let's visualize how they actually tested this, because they didn't just point a flashlight across a room.
No, they used a Fabry-Perot interferometer mounted on a continuously rotating turntable.
Right, they essentially split a highly stable laser beam, sent it bouncing back and forth between mirrors, and then recombined the beam to look for microscopic interference patterns.
And by constantly rotating the laser setup on a turntable, they could measure if the speed of the light varied even slightly depending on which geographic direction the laser was pointing as the Earth rotated through space.
It was an experiment designed to detect infinitesimal variations, and the result they captured was highly disruptive.
They did not measure 0.
They did not. They detected a minute, persistent variation in the speed of light, an anisotropy.
The laser detected a fractional shift. The variation was incredibly small, roughly 2 parts in 10 to the 15th power.
Tiny.
But it wasn't random noise. The data displayed a specific quadrupolar angular dependence and a consistent rotational harmonic.
Okay, a quadrupolar angular dependence means the variation peaked in 2 specific opposite directions and dropped in the perpendicular directions,
creating a distinct 4-lobed pattern as the table rotated.
When this data was published, it presented a severe problem for mainstream physics. Because it conflicted so directly with the absolute isotropy required by relativity, the broader scientific community largely relegated the findings to the category of unexplained systemic error.
Or highly complex instrumental noise. They basically said, the machine must have been vibrating.
Right. But TDUFT does not ignore the 1979 data. It builds a foundation on it. Dukas argues that the vacuum is not isotropic.
If the vacuum is an infinite lattice, then space itself has a physical geometry. It has a grain, like a piece of oak wood.
Yes. And if you drag your hand across a piece of wood with the grain, it feels different than if you drag it against the grain.
There's more friction one way.
TDUFT postulates that as a photon propagates through the lattice, its interaction with the geometric nodes varies depending on its angle of trajectory relative to the structural alignment of the lattice.
Therefore, a minute, non-zero directional variation in the speed of light is not an error.
No, it is a mathematical necessity of a structured vacuum.
Let me make sure I am fully grasping the magnitude of this claim. The paper is arguing that Einstein's baseline assumption of a featureless void is geometrically incorrect.
Yes.
And that this highly controversial laser experiment from 1979 actually detected the literal grain of the universe.
It is a massive structural challenge to a century of established physics. But the compelling aspect of TDUFT's approach is the consistency.
How so?
The theory mathematically derives the exact quadrupolar angular dependence and the exact magnitude of the anisotropy that Brillat and Hall measured.
Using the exact same math.
Yes, and it does so using the same foundational geometry, the same beta tensors, and the same entropy divergence terms that we just utilized to solve the hyper and spin correlation at the RHIC.
It is a totally unified approach. It uses a single set of geometric rules to explain why subatomic compass needles align at the moment of creation, and why a laser beam in 1979 moved a fraction of a nanosecond slower when pointed in a specific direction.
It attempts to demonstrate that the microscale anomalies in quantum particle colliders and the macroscale anomalies in optical interferometers are symptoms of the exact same underlying cause.
The invisible, rigid architecture of the lattice. So, what does this all mean? Let's take a step back and try to encompass the sheer scale of the mechanics we have unpacked today. We started in a subterranean tunnel in New York, looking at a highly specific, seemingly inexplicable number spit out by a multi-billion-dollar machine.
0.38.
We saw how standard physics has to add invisible parameters to make their models produce that number, but then we stepped into the alternative framework of transdimensional unified field theory.
We stripped away the idea of empty space.
And we replaced it with an eternal mathematical crystal built entirely on the golden ratio. We watched how the pure algebra of that lattice provides a perfect baseline density of 0.381.
And we explored the concept of transition entropy.
Right. How the violent extraction of information from perfect geometry into thermal reality necessitates a precise structural adjustment, bumping our pure math perfectly up to the measured 0.388.
We watched that correlation rapidly decay through spatial decoherence as the structural friction of the lattice tore the alignment apart.
And finally, we zoomed all the way out to see how this exact same master equation claims to dictate the absolute speed limit of the cosmos, forcing light itself to interact with the geometric grain of existence.
It is a breathtaking synthesis of theoretical concepts. It demands that we reconsider the fundamental nature of the reality we occupy. The vacuum is not a stage, it is the source code.
The source code.
Yes, the particles are not independent actors. They are localized geometric translations of the underlying mathematical architecture.
And I want to bring this entirely abstract physics discussion right back to you, the listener, sitting in your car or walking in your neighborhood. The next time you hold your hands apart and look at the gap between them, or the next time you look up into the blackness of the night sky, reconsider what you are actually looking at.
It's not just nothing.
The invisible space separating the atoms in your own body might not be a passive dead void. It might be a rigid eternal structure constantly vibrating with pure geometric precision.
It suggests that the visible universe is merely the physical residue of a much deeper, perfect mathematical reality.
An architecture built on the golden ratio, waiting just beneath the threshold of our perception. If reality is indeed constructed on this infinite lattice, and if the seemingly empty space around us holds the master blueprint for everything from the spin of a hyperon to the speed of starlight, well, it forces a radical question.
It does.
Does that mean that the emptiest parts of our universe, the cold, dark voids between the furthest galaxies, are not actually empty at all, but are in fact the most architecturally complex and perfectly ordered structures in all of existence?
It is a deeply unsettling and profoundly beautiful concept to consider.
And on that note, we are going to leave you to mull over the invisible grain of the universe. Thank you for joining us as we explored the hidden architecture of reality. Keep questioning the consensus, keep looking closer at the empty spaces, and we will see you next time on The Deep Dive.